my dear students. So, this is Vipin Kumar Solanki, and I am going to teach you chemistry for NEET and JEE means. So, as you might know, for NEET and JEE means we are supposed to study whatever we have in the NCERT. Means it looks or it sounds very simple, but it is not simple as it looks like or as sounds like. Because, like, if you have read the NCERT during your exams, board exams, or maybe you will be writing board exams next year, so you know how tough is this, and it's so not so easy to just read the NCERT and you will get good scoring NEET and you will get a nice medical seat in some nice government college. This is not so easy, because in NCERT from one line you can get n number of information if you read it 4 to 5 times minimum. For chemistry, I'll suggest, especially for those students who are not from CBSE board, maybe they are from the some state board, let's say Tamil Nadu or Andhra or maybe Telangana or maybe any English, any state board, and it could be maybe I'll say UP state board or any state board. So it will be very difficult for them to understand those complicated languages or the words written in the NCERT. So because I am from the state board, I have done all my education till 12th from the state board, and because of this only I suffered a lot initially when I went to the college. Like about me, if I'll tell, I have done my MSc Organic Chemistry from NIT Warangal. Warangal, if you know, is in Telangana. Okay, and NIT Warangal is one of the best NIT. I'll say top 2 or 3 in terms of placements and many other things. And I've done my graduation from University of Delhi DU, and I'm very proud of it, because I'd say that was my golden period of my life. Because as we say, like, once you'll become older, you'll, like, suppose you'll complete your MBBS or whatever degree you do, you'll become the doctor, and after 30 or 35, you will definitely are going to remember only those times where you were working hard the maximum, the time where you have struggled maximum. This was the best time you will remember throughout your life. And for me, that was my golden period, 2012 to 2015, which changed me a lot. Okay, so yeah, what where I was about NCRT. So the people who are coming from non-English speaking background, who are not very good in the English, as I was in my up to 12th class. So from Hindi medium directly shifted to English medium, everything in the DU in University of Delhi, everything was in English. So initially it was very difficult for me to understand all these things, but I tried my best. I start reading like books in the English. Like, from for example, I read Pradeep book, I read NCRT. So, and those books helped me a lot. Okay, so this is why I started preparing YouTube videos for those friends who are not able to understand NCRT language easily. So I'm going to make you the best out of it. I'm going to give you the best out of it, all the points, all the important concepts, all the tricks, everything which will be required for the NEET, which will be required for the JEE mains. Okay, so be with me, and I'll assure you, if you will with me for throughout the year, you will be definitely getting 150 plus in chemistry, minimum 150 plus I'm saying. If you'll give your 100%, you'll be getting 170 or 180. Okay, it's not biology. You know, in biology, generally people used to get very easily 180 out of 180. Not easy, I'll say, but with little efforts as compared to chemistry and physics. Okay, so it's not easy to get 180 on 180 in physics and chemistry, but it is not impossible either, right? If you try, you're good enough, so definitely you can get at least 150, 160 in chemistry as well. So like this year also, many of my students has got very good marks, like 690 and all. So I can regular from the day one. If you give your best, so you will be definitely able to crack it. The one more thing I'll just tell you before I start the lecture. See, whenever we prepare for any exam, like any national level exam, like NEET, JEE means, JEE Advanced, UPSC, or whatever you are preparing, CA and all. So there should be a driving force. Driving force is what in chemistry? Driving force means something because of which process goes on. So if you are working hard, so you have to work hard for 1 year, 2 year, 3 year. So it's not easy. If you don't have strong driving force, it is going to be very difficult. Okay, for me, driving force was like I wanted to improve my situation, my financial condition of my family, now or wherever we were living. I want to go out of from that particular place, because I didn't like much about it, the environment or whatever we are living in. So this was my driving force. My only aim was I have to improve the financial situation of my family. I have to make my parents proud about me and all these things, which made me to work hard more and more. Like even though in our time, especially in my locality, we were not very aware about JEE and NEET. We were not aware. We didn't even know IIT is a college or IIT is a exam or IIT is a degree. We didn't aware about all of these things in my school time. But still, once I entered the University of Delhi, so Delhi is a Delhi, right? So there people are coming from all over the India. People are coming from very good schools like DPS and all. So I get to know, okay, these are the things which are called IIT and IT. After that, I started preparing for IITs and all for exams, and then I got in NIT Warangal with my all India rank 258. So I have also written this exam, but for masters we have a different exam, IIT JAM, JAM for BTech and all, IIT JEE. So these are the different exams. So what I'm trying to say is because I had a strong driving force which made me to keep on moving, to keep on working hard throughout the 2 years. So that kind of driving force you should have. You should know why do you want to do this. If you have the strong reason, then you will be able to work hard. Okay, so from today I'm going to teach you chemistry. So be with me. Whatever doubts you have, ask in the comment section. I'll definitely help whenever I'll get the time. Okay, if anything you have, you can ask me in the comment section. Okay, so let's start. So I'm starting with the first chapter, which is coordination compound. So coordination compound, why I'm starting, there is a reason behind it. See, generally people are scared of inorganic chemistry. Why? Because in organic chemistry there is so much to remember and all. So I thought, why shouldn't I start with a chapter which is very conceptual, which is very logical, which can we can understand with the concept. Okay, so this is why I chosen this chapter. Also, this chapter has a nice weightage in the exam as well as overall in the inorganic chemistry. It's an important chapter, it's a conceptual chapter, it's a logical chapter, and generally we used to get minimum 2 to 3 questions from this chapter directly or in the indirect manner. Okay, so let's start the chapter. I'll go as slow as possible. Still, if you have any suggestion, you can tell me in the comment box, because my aim is to give the best to the students. Okay, my aim is to be very frank. I'll tell. I want that my students will say, okay, we want to study chemistry from the Vipin sir. So I repeat, my name is Vipin Kumar Solanki, and now let's start the session. So again, hello everyone. So we'll start the chapter. First chapter, coordination compounds. So before we start any chapter, we should know why are we doing this? Why this chapter is important? So like I have written some important points from the NCERT why this particular chapter is important. So for example, how and when did this chapter started? So in the D block and F block elements, there is one statement that transition elements have a large tendency to form complex compounds. What are the reasons? We'll do their own, there itself in particular that chapter. But why do we say this? So because transition elements means D block elements, because they have large tendency to form coordination compounds. So from there, this particular chapter has born. Who was the reason for this chapter? I mean, say who is the father of coordination compound? There is Alfred Werner, which we are going to study in the next slide. As of now, you see why this chapter is important. So coordination chemistry or coordination compounds are everywhere. Like chlorophyll, being a biology students, you might know chlorophyll have a coordination compound of magnesium. Chlorophyll, which is the green pigment responsible for photosynthesis, so there also we have magnesium, complex compound of magnesium. Okay, so being a biology student, you should tell me, not I should tell you. Okay, another thing, hemoglobin. We all know hemoglobin we have in the blood. So hemoglobin also has a coordination compound of iron. Okay, vitamin B12, which is also known as cyanocobalamin, is also having a coordination compound of cobalt. Other than this, there are many other things. For example, we have carbonic anhydrase, we have carboxypeptidase A, which have coordination compound of zinc. So there are plenty of things, but we have to only focus on those points which are going to come in the NEET and JEE mains. Okay, because those will be structured to our syllabus. So only those points I'm going to tell you, not anything unnecessarily. This will, I am assure you, I'll not tell you even a single point which is not required for the exam. I'll tell you only the things which is required for the exam. I will not overburden your mind. Okay, let's move forward. Sir, other than this, anything can you tell why, like these are important where all we find coordination compound. Yes, metallurgy process. You know what is metallurgy? Maybe this word you can understand. Metallurgy means extraction of metals from the mines, how the people extract gold, silver, or all the important metals, iron, platinum, by doing some chemical processes. So, in those chemical processes, also coordination compounds will be involved. Means in the extraction of metals, also there will be the involvement of coordination compound. From there do we extract metals from the ores and minerals. Okay, leave it. Just application we should know, like what the importance in the extraction of metal. Also, coordination chemistry has a big role. Other than this, sir, it is also used in industrial catalyst. Means in the industries, many type of catalysts are there which are coordination compound, which we are going to study at the end of the chapter. Like Wilkinson catalyst is one of the example. Okay. Other than this, analytical reagent. Analytical reagent means for the analysis of something. For example, to analyze hardness of water. Like for example, in the Tamil Nadu, we know in some places the water is very hard, like in the Coimbatore, Chennai, and all. So to find out hardness of water, also we use industrial catalyst. So now the next application we have, it is used in the electroplating. Electroplating means whenever we want to do the coating of any particular metal on the objects. For example, in the 10th class, you might have heard about galvanization. Okay, so there we use the electroplating. Electroplating means coating of metal with the help of electricity. Textile dyeing for the dyeing purpose, means coloring purpose, and is most important in the medicinal chemistry. So in the medicinal chemistry also there is an involvement of coordination compound. For example, one of the thing we have anti-cancer drugs. So a long back they have discovered one anti-cancer drug which is called cisplatin. What is the structure of this? We'll do later on. Okay, so with this, bacho, we have started the intro part, means why we are studying the coordination chemistry. So as you can see, coordination chemistry is everywhere. Coordination chemistry in the medicinal chemistry, in the plating of metals, in the textile dyeing, for extraction of metal we have coordination chemistry. For analysis of something like hardness of water, we have coordination chemistry. In the biological department, we have coordination chemistry like in chlorophyll, in enzymes, and many places. So now let's start. Who was the person who has started this thing, coordination chemistry? So Alfred Werner, right? Alfred Werner. So he is the person. He is the man who has started this particular thing, and because of him, we have extra thing to study. Okay. So he was not happy with the comfort of the student. So he said, okay, I'll give you something else to study. So he started this coordination chemistry. Alfred Werner. So basically, he, and also one more interesting fact, he was the first scientist to get Nobel Prize in the inorganic chemistry. Means in the inorganic chemistry, he was the one who get the Nobel Prize. Generally, people used to get in the organic chemistry or physical. He got the first one in the inorganic chemistry. Okay. So Alfred Werner. So first we'll do what did he do? How does he come to know that there is something called coordination compound? Okay, so Werner theory we will study. So what did he do? I'll explain. What did he started? He has prepared some compounds. He has prepared n number of compound. Okay, but only some specific compound he has studied what we have in our syllabus. So he has prepared some compounds of cobalt, chloride, and ammonia, of cobalt chloride and ammonia, and he tried studying them by doing practicals and the experiments on those compounds. So what did he do? Mainly after preparing some of the compounds of cobalt chloride and ammonia, he treated those compounds with silver nitrate. So when he treated those compounds with silver nitrate, so silver nitrate has a specific nature. It has a nature, silver has a nature to combine with halogen and become precipitate. So whenever silver will see the halogen, it will catch it. Okay, it will catch it and it will become the precipitate. So because he has prepared the compound of cobalt chloride and ammonia, so he had some idea. What idea he had? He had some idea that if I'll treat these compounds with silver nitrate, so definitely the chlorine is going to combine with silver and will give precipitate of silver chloride. And it will help me to analyze many things. How and why, we'll see. So yes. So these are the four compounds we have in our syllabus. So first look, don't get scared. I'll explain you each and everything one by one. So look at the first compound. So he has prepared first compound, which is a molecular formula COCl3 6 ammonia. How does he get to know molecular formula? Remember chapter 1 mole concept. There we have learned how to calculate molecular formula, empirical formula. So it's the same thing. So he calculated molecular formula where he saw there is 1 cobalt, 3 chlorine and 6 ammonia. Okay, fine. Similarly, second compound he have taken. So their molecular formula is COCl3 5 ammonia. In the third compound COCl3 4 ammonia. In the fourth compound COCl3 4 ammonia. Array same, yes, same. Now, what was the surprising thing for him? Molecular formula is not very much difference. Means he has taken cobalt chloride, he has taken ammonia, he reacted them. Just two things he have done, but still he was getting different compounds. Their properties were different. For example, yellow color, purple color, green color, violet color, their colors were also different. So from there he started thinking there is something wrong. You might have seen the CID, है ना, कुछ तो गड़बड़ है. The same thing, there is something wrong. So something is wrong in the compounds, that even though I am taking the same thing, but compounds what we are getting are not same, their properties are different. For example, if I'll take milk and sugar, and it's not necessary that always milk and sugar if I'll combine it will form the same thing. With the same milk and sugar I can prepare n number of sweets, right? We can prepare gulab jamun, we can prepare barfi and many more things, kaju katli and all. So basically the thing is, even though I take the same reactant, compounds could be different. Now why they are different, what is special about them, we have to study. So as I told you, he took 1 mole of, what did he do, he took 1 mole of each compound one by one. He took 1 mole of each compound one by one. So I'll start with the first case. If you will understand one case now, all are will be very easy. Try to focus on one case. He took 1 mole of first compound, let's say COCl3 dot 6 ammonia, and he treated it with excess of AgNO3, excess of AgNO3. So when he treated 1 mole of compound with excess of AgNO3, what did he observe? He observed from one compound, from 1 mole of compound, he was getting 3 mole of AgCl. Oh my God. That's all. This is what he was expecting. This is only he was expecting, because in his molecular formula, 3 chlorine were there. So he got 3 mole of AgCl. Yes, this is what he want, because he knew one silver has a tendency to combine with chlorine. So in 1 mole compound, 3 chlorines are there. So 3 AgCl I will get. Okay, awesome. Everything is fine. Great. Now, but when he took the second compound, his life drastically changed. When he took the second compound, in the second compound also 3 chlorine were there, but he got only 2 mole of AgCl. OMG, only 2 mole of AgCl. Now he thought, okay, now he is getting to know there is issue with the chlorine. In both the compound, 3 chlorines were there, but in first compound, all 3 chlorine were ionizable. In the second compound, only 2 chlorine are ionizable. Similarly, in the third and fourth compound, out of 3, only 1 chlorine were ionizable. Okay, then he might think, okay, I know silver will react with chloride ion. It can possible in second compound, out of 3 chlorine atom, 2 are ion, 1 chlorine is not ion. Means, okay, can we make it more simple? Yes. Maybe he might have thought out of 3 chlorine, 2 chlorines are connected via ionic bond. Now you know ionic bond, and 1 chlorine is connected via some other bond which maybe not be ionic, like maybe covalent or maybe something else. He was just guessing. Yes, correct. Right now, if out of 3 chlorine only 2 chlorine are becoming precipitate, so you only think means 2 chlorine are ionic, 1 chlorine is not ionic. This is what was his main point of his theory. What was main point of his theory? He said in the coordination compound, means there are certain kind of compounds in the universe in which some species are connected via ionic bond, but some species are connected via some different type of bond. What are these? I do not know. Now you do the research and let me know. Now we know those compounds are called coordination compound. I'll tell you later on if you do not know. Okay, so one thing he has treated with silver nitrate, he guessed how many chloride ion will be ionizable. Now second thing, what did he do? He measured conductance for all the four compounds. Conductance maybe as of now you do not know, but little bit conductance is related to ions, number of ions. So when he measured the conductance value, the opposite of resistance, physics, remember? So when he measured the conductance value, so he get to know in the first compound conductance value was similar to 1 is to 3 type of salt. 1 is to 3 type of salt means 1 cation 3 anion, or 3 anion 1 cation, means total 4 ions will be there. What this value was suggesting, conductance value was suggesting the total 4 ions will be there, 3 cation 1 anion, or maybe 3 anion 1 cation, total 4 ions will be there. Conductance value, because conductance depends upon number of ions, so conductance value will directly tell us how many ions were there. This was not so simple. He has spent many of years of his life to do this. Now we can understand because of him. Okay. So now Werner said, okay, I know which four ions, because your value is telling me four ions will be there. I already told you three will be chloride ion, because I got 3 mole of AgCl. If 3 is the chloride ion, if 3 is, look at the molecular formula. If 3 is the chloride ion, the remaining thing will form 1 ion. And this is how he concluded the structure. He said because total 4 ions should be there, 3 are the chlorine, so remaining will make 1 ion, means 1 cobalt and 6 ammonia will make 1 ion. Oh my god, this looks very complicated. This is why coordination compounds are also called complex compound. Coordination compounds are also called complex compound because the structure is complex. It was very difficult to study such type of ion, because till then they were only knew ions means like sodium ion, chloride ion, potassium ion, fluoride ion. They didn't know such kind of weird ion is also possible where many atoms are there. Okay, this is why coordination compounds are also called complex ions or complex compound. This is how he concluded his structure for everything. Quickly I'll explain. So in the second compound, like conductance value told us 3 ions will be there. Werner said, okay, I know, listen to me, 2 ions are chloride ion, means 1 ion will be the from the remaining whatever is remaining. So 1 cobalt, 5 ammonia, 1 chlorine, all of them will make 1 ion all combined. How did I get to know charge? Array bachcho, it's very simple. Cross multiplication. In 10th we have done now. So 2 chlorine means 2 negative. So on the complex it will be 2 positive. Cross multiplication. Have you done like MgCl2? So cross multiply Mg plus 2 Cl minus. Same thing. So 2 chlorides are ionic. So plus 2 charge will go on the bracket. Okay, so whatever we are writing in the square bracket, they all will together will make one ion. This is called complex ion. Similarly for the third one and the fourth one. Now some people might be thinking, sir, in third and fourth, molecular formula is same. Why their color is different, sir? Why their properties are different? Their formula is same. They are giving same number of ion. Everything looks same. Structure formula is also same. Why they have different color, different property? But you remember 11th class, the compound which have same molecular formula but different properties are called isomers. Sir, isomers, we remember, sir. We are very intelligent people. So, these two compounds are isomers. The last two compounds are isomers. So, just remember it. Okay. So, this was Sir Werner experiment. He has spent many years and he has studied all these compounds and he has concluded. What did he concluded? He has given us some rules which we are going to study in the next slide. So these things generally they don't ask in the board exams and all, but in NEET and JEE means they can ask. Like because they are in the NCERT. In the NCERT, we cannot escape even a single word, even a single graph, even a single table. Each and everything I am going to explain you with proper clarity, with trick also, wherever trick is possible to remember. Okay, so these compounds they can ask like which compounds have analyzed by Werner sir, or what did he observe, which properties did he analyze, what experiment he has done, all these things. So now after doing all this hard work, what did he conclude? He said, okay, listen to me, I'll give you some postulates you should understand and remember. So he said, in the coordination compounds, in the coordination compounds, there will be two type of linkages, or in a simple word, bond or valency. In the coordination compound, central metal means metal which is combining everything, the central metal is going to have two type of bond, out of which some are ionic, some are not ionic, and he has given name primary valency and secondary valency. He said coordination compound are going to have, in the coordination compound, metals are going to have two type of valencies, primary valency and secondary valency. Okay, great. Second point, what is primary valency, what is secondary valency, we will see. Okay, so primary valency is ionizable and equal to oxidation number. Oh, means, as I told you, in your mind just think this way. That Werner ji told that there will be two type of bond, ionic bond and something which is not ionic. In his time, he didn't know it is called coordinate, but now we know it is called coordinate. So in a simple word, if I'll say, Werner ji said coordination compound will have two type of compounds. What two? Sorry, coordination compound will have two type of bond. Coordination compounds will have two type of bond, ionic bond and something which is not ionic, which he told primary valency and secondary valency. So he said primary valency is ionizable, means primary valency is something which will be ionic in nature. That means whatever species are connected via primary valency, they will be ionic in nature. Now you can relate, like in the first compound, all three chlorine were ionic because they were connected via primary valency, and primary valency will be equal to oxidation number. So in today's time, in the exam, whenever they ask you calculate primary valency, that means you have to calculate oxidation number. Okay, it's going to be very simple. Next point, the another type of valency, the another type of bond, or the another type of link is secondary valency, which is not ionic in nature, which is non-ionizable. Like in the second compound, I'll show you again. In the second compound, out of three chlorine, only two chlorine were ionic. That means he said maybe in the maybe the secondary valencies are those which are not ionic in nature. So non-ionizable, and this is called equal to coordination number. What is coordination number? I'll tell you one second. So secondary valency equal to coordination number. Which a coordination number, as of now I'll tell you in detail, we'll study in the next class. Coordination number means you can say neighbors. Coordination number means neighbors. How many neighboring atoms are there? Exactly, this is not the meaning. I'll tell you it later on. Okay. So primary valency is the oxidation number. Secondary valency is the coordination number. This is what he said. That metals will have two type of bonds, two type of valency. Okay, let's move on. Primary valency will be satisfied only by negative ions. By primary valence is something related to ionic nature, something related to charge. So only negative ions can justify or can satisfy that valency. Because just now I told primary valence is oxidation number. So oxidation number is only related to ions. You might know it is only related to, it will only be calculated with the help of charge. So this is what he said, primary valence is satisfied ions, whereas secondary valence is satisfied by neutral molecule or negative ions. Okay, neutral molecules or negative ions. So whether you have neutral molecule like H2O, or you have negative ions like chloride ion, like in our example, in Werner example, ammonia, for example, in the second thing, you if you say ammonia and chlorine, both are secondary valency. Okay, are you getting my point? I hope. So we are saying primary valence is satisfied by negative ions, by the charged ions, but secondary valence is satisfied by neutral as well as negative ion. Because primary valence is oxidation number, secondary valence is coordination number. Coordination number is what? Coordination number is number of coordinate bonds. Let's say I'm telling you now itself, okay, because otherwise it will be difficult to understand. Coordination number is total number of coordinate bond. In detail, I'll tell you later on. Total number of coordinate bonds. In any compound, how many coordinate bonds are there? That is called coordination number. So they said coordinate bond can be formed by anything. It can form by neutral molecule as well as ionic molecule. So secondary valency will be satisfied by any kind of molecule. Okay. Coordinate bond, you know na guys. Coordinate bond means like when one atom is sharing both the electrons, another atom is just accepting it. Like in your schools and all, you might have feel there are always, we have certain type of friends who never share their lunch but they will eat your lunch. So basically you are forming the coordinate bond. If you are giving your lunch to the your friend and he is not giving you the food, that means you are making the coordinate bond. You are giving your lunch to the person and he is just sharing it, he is just accepting it. Okay, that is called coordinate bond. Okay. So last point of Werner theory, primary valency is non-directional. Yes, primary valency is nothing but ionic bond. If you understand in a simple word, so ionic bond is just a force of attraction. It can take place in any direction. This side, piche, like back side, front, anywhere. Like wherever you have ions, they can be attracted from any particular direction. So it requires no direction to form a ionic bond. So primary valency is not directional, but secondary valency is directional, because secondary valency is related to coordinate bond, and coordinate bond is formed by sharing of electron. Now remember 11th class, sharing can only happen by overlapping of orbital according to VBT theory, and overlapping cannot happen in any direction. Like px can overlap with px, py can overlap with py, not px cannot overlap with py to form bond. So the thing is, coordination number can only be formed in a particular direction. Okay, in a particular direction. This is why secondary valency is directional in nature. I hope you got the point. And because it is directional in nature, so it will decide what will be the geometry of molecule. So depending upon what is the coordination number, 2, 3, 4, 5 means how many coordinate bonds are there, we are going to tell what will be the geometry. Like in the 11th class we have done tetrahedral, square planar, octahedral, trigonal planar, all those things. Okay, bachcho. So this was the Werner theory. I tried explaining in the simplest way. I'll just quickly conclude. Werner theory has said in the simple word, there will be two type of bond. There will be two type of valency in metals in the coordination compound: primary, secondary. Primary is ionic in nature. Secondary is not ionic in nature. Primary will be equal to oxidation number. Secondary will be equal to coordination number. Primary will be non-directional, secondary will be directional. Primary valency can be satisfied by negative ions, secondary valency can be satisfied by any kind of molecules or the ions. Okay, done. This is Werner theory. If they ask anything from you in the exam, they will ask you from this, not anything out of this. They will not ask you anything out of the box, only postulates they will ask. So based upon this theory, we can understand little bit. I'll just give you some idea. So this is how we represent any coordination compound. So whatever we write outside the square bracket is a way of writing. There is no reason behind it. It's a way of writing. So whatever we write outside the square bracket is ionizable. Means it is connected via primary valency. And whatever is representing inside the square bracket is connected via secondary valency, means is connected via coordinate bond, hence it is not ionic in nature. So this is why the whatever we write inside the bracket is called coordination sphere, okay, or coordination entity, because coordinate bond is there. So coordination sphere or coordination entity or complex. Why complex? Because it is very difficult to understand. means what all atoms are there inside the bracket. Means if you are doing some experiment in the lab, now in the notebook and all we can understand nitrogen is there, hydrogen is there, but while you are doing experiment nothing is visible. So it is very difficult to understand in the square bracket what all will be there. This is why we call them complex compound. Okay, so this whatever we are writing in the square bracket is called coordination square or coordination entity or complex, and it is non-ionizable. Whatever we are writing outside is called ionizable or simply ionization sphere or counter ion. Anything is fine. So with this, bacho, accordingly the Werner theory, the Werner G, whatever he has done is over. So because of him, we are going to study this chapter. This is called Werner theory. Now from here onwards, we are going to continue the chapter in the next class. Just one last thing, we will do one question which is there in the NCERT based upon this concept. I'll explain you one compound, rest you have to practice at home. Let's say on the basis of following observations made with the aqueous solution, assign secondary valency to the metal. So they said depending upon this observation, tell us what will be the secondary valency. I'll help you. For example, in the first compound, they are saying they got 2 moles of AgCl. They got 2 moles of AgCl. So first compound, if 2 moles of AgCl means both the chlorine will be ionizable. If both the chlorines are ionizable, so both the chlorines will be outside the square bracket, and in the bracket what will be there? Palladium will be there and 4 ammonia will be there. Palladium will be there and 4 ammonia will be there. So they are asking, based upon this observation, tell us what is the secondary valency. What is secondary valency, bachcho? I told you secondary valency is number of coordinate bond. So whatever number of molecules are there generally, in detail as of now I cannot tell you because as of now we just started the chapter. So 4 ammonia are there. So 4 bonds are going to form. 4 coordinate bonds are going to form. So coordination number will be 4. Okay, or you can say secondary valency will be 4. Okay, similarly please try others as well at home. I'm attaching the answer key. You can refer this and practice at home. So now the last thing. So from my heart, thank you everyone. Thank you. Okay, thank you all for your patience, and I hope you like the session. If anything you have to tell me or to ask me, you can tell me in the comment section. My drawing is very bad, I know this. And this is why I chose chemistry to teach, not the like arts and all. Okay, so yeah, thank you all for your patience. If you like the session, subscribe my channel and hit the bell icon, and whatever concern you have you can tell me in the comment section. And yes, I hope I'll keep you teaching all these concepts, and it will be keep on learning, and definitely you are going to become doctor by end of the year. Thank you. Bye bye.